Hello, and welcome to another episode of Hacking with Friends. My name is Cody Kinsey. I'm a security researcher at Varonis, and today I'm joined by my co-host, Michael, who is our production manager and Bigfoot expert.
Indeed.
So today we're going to be going over something that I think is really cool and exciting if you ever wanted to create your own home lab for Wi-Fi hacking. Now, in the past, I've recommended that maybe you get a Raspberry Pi, or you can simulate certain parts of Wi-Fi hacking by using something like an ESP3266. And I'll unplug and pull this one up here. This is a D1 Mini. They're really cheap and easy to come by, like $3. I got this for like $1.80. And you can use this to do all sorts of interesting Wi-Fi stuff. And our good friend Stefan, who unfortunately couldn't be here today to tell you to buy his product, which I'm sure you'll find on his store, spacehoon.store anyway. But yeah, like this is the test bed that you'll need to do a whole bunch of cool Wi-Fi stuff like creating fake access points, attacking access points, scanning. But there's one limitation with this, and that is the fact that when you create a soft access point or you create a Wi-Fi network with this, it doesn't really behave like a real Wi-Fi network does. So that's really kind of interfered with my ability to create like fun Wi-Fi hacking games, because you can't really emulate the full range of Wi-Fi behavior on a device like this. Now, there actually is a project I'm going to be trying out to see if I can get up and running that will try to do something similar with this less powerful chip than, for example, the ESP32. But still, these little microcontrollers really have to push themselves hard in order to be able to emulate something like a router, which is what is a little bit harder to come by for people that are learning Wi-Fi hacking, don't want to get in trouble by attacking maybe a shared router, or maybe just don't have permission to attack any nearby Wi-Fi networks. So what Stefan and I have been trying to do is make a series of games that use the ESP8266 in a couple different basic configurations, and we've kind of succeeded. For one, we've been able to make this pretend to be two devices at the same time and give up handshakes that you can try to crack if you're learning about handshake cracking. We did a game at RSA where we had two of these, one of them creating an access point and the other one acting as a client, and this one would just join the access point over and over and create handshakes. It was really easy to change it. We taught people Wi-Fi hacking, but there were some things we couldn't do. So one thing we couldn't do is have like another level of the game where they have to scan the Wi-Fi network after they join it and they crack the password and find a service and connect to it, because this isn't actually acting like a router would, where it would allow you to connect to other devices on the local network. This, in fact, is limited by the fact that when it's acting as an access point or a soft AP, it's not able to do the kinds of routing that would allow you to connect other devices to it and then communicate between them. So this has been a limitation for a while in the kinds of games we can put on, because people really want to take the next step after they break into the network. They want to see what's on there, and frankly, you kind of can't really do that with a device like the V3D Author, which I've been working with Stefan on. So you can make the appearance of a Wi-Fi network, but there's a couple ways that someone would pretty quickly figure out it's not really an access point. The first would be there's no data. So these cannot provide any data, because in order to do so, they would need to connect to a Wi-Fi network and then relay that information back and forth between devices, which is a lot of work. So there, again, is a project that claims to be able to do that on this little ESP8266, but I haven't been able to get it to work personally. So I'm not saying that it doesn't work, it's just not well documented, and it doesn't seem like it would really be an option for most normal people. So today instead, we're going to be using the ESP32, which I'm going to pull up an example here. Now this is, if you're just looking at them all small, there's probably not that much difference. They look pretty much about the same size, but this ESP32 on this side is just a little bit bigger. And it has some additional abilities, like it has built-in Bluetooth, built-in Wi-Fi, as opposed to just Wi-Fi on this one. And it also has a beefier processor, so it's able to do things that this would have a harder time doing. Now, this ESP32 is actually able to act as a router. So what that means is we're able to connect this to an access point that's giving up data. Let's say that it's our home Wi-Fi network that we were not allowed to attack, but we connect this to it, and then this creates its own access point that other devices can join and actually get data from. And even better, devices that are connected to this network will be able to interact with each other. So I can scan the network, I can maybe like do some ARP spoofing, some DNS spoofing, or I can do some brute forcing of services on other devices that are connected to this. And in fact, we did a little presentation where we used a D1 Mini to act as an FTP server, and we connected it to, you know, our access point. And then if anybody broke into our access point, we would be able to know when they connected to the FTP server. Usually they'd have to brute force a password, and when they managed to log in, it would trigger an alert through a canary token. Really cool, just a little honeypot to catch people messing around in our network. If we wanted to, we could create a completely separate network from our like highly secured network that still gets data, but maybe has a not so good Wi-Fi password. And we could connect a service to that. And if anybody were to break in, it would seem like a real Wi-Fi network because, you know, it would be able to get data, and it would have, you know, maybe an FTP file share on it for them to try to attack. So as soon as they did, we would know, because this would be able to trigger the canary token and warn us. So we could have maybe one of these like perimeter access points around, just being low-hanging fruit to let us know if somebody's actually, you know, trying to break into networks in the area. So
that's actually a really clever idea. Like, just make it like with password 123 or something like that, and you'll find the hacker real quick.
Yeah, so this can absolutely act as a honeypot if you want it to. It can act as actually a NAT router. So you can just connect it to, especially if you have one of the versions of the ESP32 where you can like put an extended antenna or something that's going to get better range, you could connect this to an access point and then relay that access point. And I actually got pretty good speed. I was kind of amazed actually at how it was able to do this. So
when you say pretty good speed, you mean like 5 megabits?
We'll see. We'll actually go ahead and test it. But it was enough that I could stream videos on it perfectly
like
fine.
YouTube?
Yeah, like YouTube.
Wow,
Yeah.
that's impressive. Because like the one thing I would immediately think would be a limitation with this is that it would be super slow.
Well,
especially
it only has one radio, so it's automatically going to be at a disadvantage. So for hackers or anybody else that like wants to have like their own little router like contained in an ESP32 chip, this should work on most ESP32 chips. The process was just a little bit sketchy to get started with, and I had to dedicate some time to learning how to do it. But I'm really excited about this. The code is also just open source, like it's available for anyone to work with and modify. So you'll probably see this feature crop back up in SpaceHoon's future products because we're talking about how we can turn this into games and other stuff. But I just find this tremendously useful because again, this could be something like that sits outside, just barely in range of your Wi-Fi network, and maybe you have some IoT devices, you know, around the perimeter of your yard or
like
something.
a Wi-Fi extender almost.
Exactly. That's exactly what this acts like. So this acts exactly like a Wi-Fi extender. So if you either have an access point with an antenna that's pointing right towards it to give this like a good signal, or you know, you attach like a bigger antenna to this, you could make it so that this is able to provide access to a pretty big area.
I mean, I think that's a legitimate use case, is like just putting it in a watertight enclosure and maybe just putting a nice like omnidirectional antenna and just putting it out in the yard somewheres, even just for your own IoT products.
I was pleasantly surprised. So we're going to go ahead and try it again today. We're going to connect it to a different network and see if we can get it to, accept it. And then we'll join the network and see about actually getting a good speed. But first, let's go ahead and demonstrate what happens if we try to do this without using this handy ESP32. We're going to try to use a microcontroller to create an access point using the deauthor, and we're going to see what we can do.
Okay.
So let's go ahead and switch over to my screen. I'll enlarge that. And this is the SpaceHoon's navigator. We're going to be using this to interface with the...
Have we shown this on the stream before?
Yeah, we have.
Okay.
Like twice. And then I also have, I think in Firefox over here, no, that's not it. We're going to try to find the...
Should I go away from your screen?
Oh, no, that's fine. What's the port number of your computer, or the IP address of your computer? So basically, I'm going to show off what we're going to be trying to connect to here. So it's probably going to be either in your other terminal.
Yeah, so it's .1.100, and then I think it's on port 80.
Okay, it's just 100. Okay, cool. So here, hopefully this works. We're going to try to connect to a server that's being hosted on Michael's computer. Okay, so after restarting the Python script, we have what we are looking to be able to access here across the network. We are currently going through a router, and I can connect to Michael's computer that is hosting a secrets.txt here. And this works across the network. If I want to verify this, I can go to a terminal instance, and I'm going to go...
Can you make that huge?
Yeah, I will. I'll have to make
And full screen.
There we go. All right, so what we're going to have to do is sudo nmap 192.168.1.100.
And so for those that don't know, Nmap is just a typical network scanning program.
It is the best network. Typical of what?
It's normal,
There's nothing else
old
like Nmap.
school, classic, no, vintage.
Okay. Yeah, so we're going to run Nmap, which is going to go ahead and scan this IP address and show us exactly what services are available on it. So it's going to go through and check all the different ports and see if any of them are open, and hopefully if any of them are open, it'll give us an understanding of what is happening on them.
Okay, so it's oh wait, no, it's scanning just mine.
It's just scanning one, so I have no idea why it's taking
Why is
so
it
long.
taking?
I don't know. Our test network is an old router, and it actually kind of sucks. So yeah, I don't like it, and it is annoying. But as this continues, it's very, very slow scan. We should be able to see port 80 exposed, and that's what we're looking for here. Just
That's
the ability
actually
to
why
see.
I like Fing better than Nmap.
Well, it's not. Nmap is not the culprit here.
Yeah.
You could run Fing on this terminal, and it would take exactly as long because, this is. Oh my gosh! Yeah, 43% done. Wow, that's amazing.
Okay.
Why though? Yeah, so like this is like pretty wonky, but you can see like we can put in 192.168.1.100, and eventually, after thinking about it for an incredibly long time, Michael will get a GET request, and then boom, we get secrets.txt. So it is working just very slowly, and wow, Nmap is still considering what to do about this whole situation. It's really 43% done. Wow.
That's really weird.
Well, yeah, this is just like a very, very...
I wonder if we're like too close to the router.
I'm literally scanning one port Nmap. Host seems down. See, yeah. Okay. Let's do PN. Oh wait, no, I have now because I know it's going to take forever. I have to do P80. All right. Yeah, so my computer is completely convinced that like this is not up, and on an Arp Scan -L, I can see that it doesn't even see 100. So there's like a weird routing issue going on. So as you can see, even with a router, just trying to access a service on the local network is problematic.
Okay, yeah, no, on my computer, I just got an error. Exception error occurred during processing, blah, blah, blah. Connection reset error.
Yeah, well, it doesn't matter because look, I'm pinging your computer and I can't even see it on the network. So like there's some like very funky, like weird routing stuff going on. So that's really cool and interesting. Let's see if we can create a scenario where we can connect to the stupid secrets.txt over a network. So first up, we're going to use a microcontroller to do this. And we're going to use Spacegoon's Navigator. So let's see. All right, and first, one thing to notice is like when I do this ARP scan, I'm not seeing anything, like except for the router. Oh no, wait, no, never mind. Now I see .100. Before I was seeing 102, which is my phone, which is also connected, but for whatever reason, I can only seem to see. There we go. All right, the whole gang is here.
I was going to say,
finally.
I might need to reset the router.
Yeah, no, well, that would have been a great thing to do before we started the broadcast, but we're here now. So, and we're going to be switching away from it pretty soon. So we can, for whatever reason, we can now probably ping it as well. Look at that. Yes. No.
I was going to say, do I need to wait, no. Okay, so the service seems to still be going.
Yeah, well, whatever. So, all right. Let's go ahead and connect to the deauthor. We're going to select the port, which
and
is...
so the deauthor is just plugged into your computer?
Well, in this case, a D1 Mini running the version 3 of the deauthor is, yes, plugged into the computer. Serial port pops up from this website. I'm going to connect here. And then I should be able to get a list of all the commands by just typing help. There we go. So I'm going to do demo-m on to turn the demo mode on, which will save Michael a little bit of blurring. But really what we want to focus on is AP. We're going to create an access point. We're going to call it testnet and we are going to not include a password. So we're just going to go ahead and let that be
Wow.
an open access point.
Living life on the edge. Really risky behavior.
Okay. So go ahead, and this is what we're going to do. So, Michael, am I sharing over the network, my screen?
No.
Okay, great. So if we both connect to this network, go ahead and connect to the test net access point, which should be pretty
So
prevalent.
I need to kill the website hosting service.
No, just
No?
no.
Okay. I don't see testnet.
Just wait for a second and you'll see it. And once we're on testnet, we should both be on the same network and able to see the same, I guess, like access point host, like the device that's putting out the Wi-Fi network. But I don't think we're going to be able to see each other or interact with each other. So we're going to go ahead and see. I'm going to go over to my terminal window. I'm going to sudo arp scan tac L as Michael.
I'm just going to do it now.
No, please don't do that. That's going to connect you to a hidden network, and the computer will always call out testnet forever. So I'm going to run an ARP scan, and I can see I'm connected to something that's Storage Computer Corporation 192.168.4.1, and I don't think that there's any services running. Sudo nmap 192.168.4.1. We'll see if there's anything going on there, but my imagination is no, nothing will be up there. Did you? Yep, there's testnet.
Now I can see testnet.
Cool.
Yeah. Sorry, no, the Mac here was having technical difficulties, you might say.
Okay, so Michael is still offering up, well, actually, this is what we'll do, just so we're doing this accurately. Oh, we can see there's actually a port open here. That's interesting on 192.168.4.1. So if I wanted to go over and see what that was, I could go ahead and do that. And look at that. It's trying to steal my password. I'll submit it. You can see this is just the phishing page that we set up. Oh, wait, where's my navigator? There we go. Yep, my password. So
I could not join testnet.
Run
diagnostics?
No, press cancel and then just join it again.
Okay.
Yeah, cool. So as soon as Michael joins, then I'm going to have him stop hosting the file server on the old IP address. We're going to press just cancel it and then restart it.
It seems like it might be connected now.
We'll find out. So go ahead and just
Cancel this.
cancel.
And restart.
There we go. Cool. So Michael is now serving up this port 80 on his computer, and we are both connected to the same network. So I'm going to run another ARP scan, and I don't see him. And the reason for this is, and I can continue to do ARP scanning and stuff, but the reason for this is I'm just not connecting to a network that allows for the kind of routing that would let me see if there were other devices there, let alone interact with them.
Right.
So if I do sudo nmap, and then what's your IP address on this weird network?
Because it's saying that I don't have internet access, but I don't...
Yeah, that's because this won't have internet access.
Yeah.
So this is an ESP8266 that's not connected to any other access point. So we're just telling it to create a fake network, and it should still assign you an IP address. It should be under ETH0.
169.254.
169.254.
116.222.
All right, so Michael's hosting something here, and I can't ping it, I can't nmap it. There's no way for me to communicate with this. I have to sudo that.
That's a really weird IP address too.
Yeah, so as you can see, like, we can't communicate with this. So we have the illusion of an access point here, but it doesn't have internet, and it doesn't allow routing internally. So even though Michael's hosting a file server, which you can cancel now, we still cannot see it. So let's go ahead and I'm going to plug this in. This is the ESP32. I'm going to unplug my other deauthor device. And we're going to see if we can do something a little bit more legit that actually does the kind of routing we're looking for. So I'm going to run ls-dev-su in order to find the port number that this is at. And it looks like it's on this one, the slab to USB UART. So I'm going to copy this. And then I'm going to go up a little bit. And there's a series of commands, which are pretty, there we go, pretty distinctive, that look like this. And this is like a bunch of compound commands we're going to use to flash this project over. So let's take a look at the actual GitHub.
A whole boatload of commands.
So this is the project we're going to be using today. It's the ESP32 NAT router by Martin Gurr. And this was difficult looking to flash over until I realized that it actually uses the ESP tool, which is something we've done many times before. ESP tool is based on Python. It's really easy to install, and you can get started using it pretty quickly. So it allows you to create a web interface, which you can then put in the credentials for the access point you want it to connect to. And then after that, you can use the ESP32 as the device that you're using as a punching bag. And you can easily change that information as well. So there's a command line interface that's exposed over serial, which you can basically tell it to do whatever you want it to, update the variables and settings so that it's a different access point name, it has a different password, all via command line, which is really cool. So in the ESP tool, we have to go to the project directory and then enter all of these together. This is a compound command. I tried running them one by one, and that is not what they meant for you to do. It's literally meant to be run like this after you join the project directory. So I'm going to go and let's see. I'm already in the ESP32 NAT router master folder, so this should all work. But I also need to make sure, oh yeah, I can see here that my my port should also be the correct one. So I think I should be able to run this without any modifications, and we'll see what happens.
Hey, looks like it's flashing.
Yeah, that's not a positive sign.
Are we going to brick it on live stream?
Bricking is not really something that happens to microcontrollers.
Sad.
Yeah, so this sad little heartbeat means that unfortunately something has gone wrong. Okay, so in our previous attempt, this little chip fried itself. So we just spent a bunch of time trying to figure out what was going wrong, and it turns out this chip just killed itself. It doesn't respond, it doesn't react. Probably got a little piece of metal or something in there that shorted it, but either way, this chip is dead. So it connects over serial, but we couldn't do anything. So I'm going to go ahead and run this command, which is taken directly from the project here. And we're just going to specify that we're doing it over USB to UART. Going to press enter, and it's going to go ahead and connect. And instead of giving us that flash of death where it's not receiving anything, it's going to go ahead and flash this project over. So yeah, it's kind of weird. I don't see any physical signs of damage on this, but there's also no output. It doesn't create a Wi-Fi network, and there's no indication that it's really doing anything. So because we can no longer communicate with this over USB, and also it's not running the program that we flashed to it, I'm going to say that this is probably broken. So wow, that didn't take long. I guess make sure to put these in a case, because if you have them just like loose in your bag, they can get destroyed.
I wonder if it got popped by static. I know that's awesome. I know that's a risk potentially, but like I've never really taken static precautions around circuit boards and been fine.
Yeah, no, I mean like this thing like was working as of the beginning of our show, so it's kind of annoying. So all right, I'm gonna now that we have the port number and everything, I'm gonna try connecting to this since we've flashed it. So this is the port that it is. I'm gonna say, I did that preemptively. Let's do screen. Port number, and then 115200 for baud rate, and help. Get anything? Yeah. Okay. Cool. So it looks like it's operating.
Victory.
We have access to this this interface. So now I'm going to go ahead and look for it, and I should see there should be an access point named ESP32 NAT router. I'm going to connect to that, and I can see immediately we've got some stuff going on. So I can see that a DHCP lease is being established to give an IP address to this new device it's connecting, which of course is my computer.
That seemed really easy. Like, I mean, once we figured out the problem with the board, that's just one command to get this all installed and running.
Yeah, yeah. Well, I mean, presuming your thing isn't dead, but yeah. So over here, I'm going to go ahead and, why am I in the harvester? Who cares? I'm going to go sudo arp scan -l, and let's see the results. Well, there we go. All right, so we have 192.168.4.1, pretty standard for a microcontroller. If I go over to here, we do not have internet at the moment. Um,
Okay, so I joined and I didn't have internet, and then I just got internet. So I don't know if it somehow is giving me internet and not giving you internet.
What network are you connected to?
The ESP.
Okay, and you can ping like Google.
Let's see.
That would be very interesting.
No route to host.
Okay, yeah. So I was gonna say like something along the chain is lying. So right now we don't have internet, but if I go to 192.168.4.1, it gives me the ESP32 NAT router config. So right now we have the SSID of ESP32 NAT router. I'm going to make it test net. And I'm also going to provide no password. So this is going to be just an open network. So I'm also going to require change the station settings. So this is the uplink Wi-Fi network. So let's go ahead and copy this over. So I'm going to have to copy over the TP link. Just read it to me. TP
link.
Is it all caps? No, it's all caps.
TP-link
All right.
_ 3B19.
Is that all caps too?
No, that's right. It's a capital B.
Yeah, it is. Okay, cool. So it is all caps. Cool. All right, and then the password. Okay, so I'm going to click on connect, and this is going to go down for a bit, and then when it comes back up, we should now have a data connection. Although I don't think I saved, all right, I didn't save the SSID as something else yet, so I'm going to save this as testnet and set it, and it's going to kick me off because now I've changed the SSID, and it won't be the one that I was connected to before. So hopefully Michael and I will both see the network called testnet, and this is going to be the one that we've actually set up. Yep, I see testnet. I'm going to connect. There's no password. And now I should actually have internet. So kind of can't see in the shot, but the LEDs on the ESP32 are acting like network lights, and you can see it like reacting to us joining and stuff. So I'm going to go ahead and look at the terminal. The other terminal, there we go. We can see, yeah, we're establishing sessions. We're able to see kind of the general kind of traffic that's going on. We've got 2 stations connected. Great. All right, so now I'm going to go ahead and in this terminal, I'm going to do the Arp Scan again. And hopefully, if Michael's connected, are you connected?
Yeah.
Hopefully, I was going to say I'd be able to see Michael as well, but nothing is working properly on this at all. So let's do sudo nmap. We're going to do the entire network range, 024, and then we're also going to specify P80. And can you go ahead and start that service again?
I already have.
Okay, cool. And then we'll do -- open so we don't waste our time with stuff that's not up. Okay, so we see that there is one device on the network, and it's an Espressif device, and that's the only thing up. It's apparently 192.168.4.1.
And it's testnet, right? I'm connected to testnet.
And yep, it's connected to testnet. So what IP address does it say that you have? Oh, it does say that there are 3 hosts up. So let me get rid of the port 80, and I'll see what else is. I guess we'll see what else is up. Although now I've made it so that I have to scan a lot more ports, and the network lights are going crazy. So you got an IP address?
You said that's where it should be, right? If I don't see it.
Are you sure? Are you sure you're connected?
Yeah. Let me ping Google. Just. Yeah.
No, I mean to the correct network. Just like double check. Testnet. Yeah, so you've got a connection, but let's see. So you are not 192.168.4.3?
I might be 4.3.
Okay, all right. Because so far the only other device I see, we have Espressif, and then we have 192.168.4.2. That does have a port 80 open, so let's go ahead and check that out. 192.168.4.2. Maybe that's Michael. Who
Yeah, it was
knows?
the second one to connect. Right.
We're gonna plug that in. There we go. We can see secrets.txt, and I can read it, and it's a bunch of stuff about how insurance works on Turo. Great to know. So what have we done here? All right, well, we've set up a network that allows us to successfully connect to other devices. And now Michael has internet. So that's really cool. So I'm going to go over to my terminal window, and I'm going to sudo Wireshark. And real quick, we're going to use this for one of the many, many things we can use this for. I'm going to go here. I'm going to look for beacon frames. And if I want to filter, I can just click on this, find beacon frames as a type, and then apply as filter selected. Then here in the beacon frames, I'm going to need to see what they're advertising. What network are they talking about? So here we can see WLEDAP. That is not what I want. However, it is something that I need to be looking for. So I'm going to apply this as a column, and that should hopefully, if this isn't huge, allow me to, oh, there we go, to see the SSID that it's trying to connect to. There we go. So we're looking for testnet. Here we go, testnet. So we eventually want to write something that's a filter that just shows all traffic in and out of testnet, which we've now identified by its beacon that says literally testnet. So we're going to go here. This is the transmitter address. We're going to apply this as a filter, and we're going to do the same trick we did before. We're going to copy this, add a pipe. Oops. Well, that didn't copy at all, did it?
No.
Copy. Paste. All right. Get rid of this again. And what we're going to do is we're going to make the DA, the destination address. So anything that's to or from this MAC address we want to see.
And if you find any of this confusing, we do have a previous live stream on Wireshark Basics that you might find helpful.
All right, so now it's showing like 15% of all packets, and we can start to see the kind of stuff that's here. So we can see the beacon frames, but we can also see data packets. And because this is unencrypted, Michael, I'm going to ask you on your computer to go to mydougal.com.
Okay. Good old Dougal.
Yeah, we're going to try to intercept what Michael's doing. mydougal.com, please.
I'm going, calm yourself.
All right, beacon frames,
and
quality
I'm
service data.
Still on testnet.
Yeah, you should be. All right, so we're getting some other types of, oh, I'm on low battery too, but we're almost done here. So, all right, we're getting all sorts of data.
It's loading. It's just very slow.
We can see here we've intercepted a request to mydougal.com. That's very good. Now I want you to, as soon as it actually loads, type in your username and password. In this case, just make it admin.
Okay, I was going to say. See, connect all.
Okay, so I'm going to go ahead and, well, as soon as that request completes, all right, I'm going to stop. Now I want to go ahead and dig around in here a little bit. So let me use the magnifying glass. I'm going to, did you do admin?
Mm-hmm.
Let's see if we can do it in a string somewhere. Maybe it's in a string somewhere. No packet contains the string. This is actually a lie. So we're going to look in the packet details. We're going to press find. Oh, look at that. We were able to find admin.
Oh, you intercepted my password.
Form name admin. Pass admin. Yep, here we go. So we successfully intercepted Michael logging into his Dougal. And we did that because we created an open access point and we're able to sniff on it and see this. All this, again, being possible because we're using an ESP32. So yeah, very, very cool. We've gone from using the ESP8266 to create an access point that just like doesn't actually do routing or give you internet to using a ESP32 to create an access point that does have internet and does do routing. I could use it to see services running on his computer and connect to them, brute force them, whatever I want to do. And I could use them to create an access point that has internet, but no security. So like one theoretical downgrade attack you could do is you could have one of these in like an internet cafe or something that has Wi-Fi that requires a password. You could connect this to the network that requires a password and then just make this an access point that has no password. This is basically passing along the internet, and anybody that connected to it, you would be able to see everything they were doing, provided that they didn't use a VPN or something. So, and Michael, if you want to do a speed test while yeah, so to be fair, I have done a speed test on this before, and it was pretty reasonable. However, we are connected to a network that absolutely already sucks. So I'm not really sure what we're going to be able to reflect on.
Well, given the fact that the speed test website isn't even loading yet, I'm gonna say it's gonna suck.
Yeah, but at the same time, I kind of feel like it's not this little thing's fault, because just doing a speed test on the regular network, I think also is not very pleasant.
Well, on our home network, it does fine.
Don't you? You always use the same speed test, yeah.
Yeah, I always use speed of me.
Dumb. All right. Yeah, sure. Accept start test. So I'm just comparing it on the straight up, like I've connected to the
Home network?
no to the TP link,
Okay.
our test one, and you can see it's like all over the place and kind of spotty. Now, when I tested this upstairs with a slightly better connection, I was able to, again, stream and have 3 devices connected at the same time and be able to use the internet kind of almost normally. So, yeah, I was actually really impressed that this was able to forward connections and be able to do all that stuff with such a small package.
Yeah, it won't even
So-
start the speed test on the Mac.
You mean on the ESP32 network?
Yeah, on the ESP32
Okay.
network.
Yeah, so I can see this is clocking in at 101 megabytes per second download. If I guess I'll do it. If I connect to testnet, we'll see what we can actually do. No. Oh, there you go. All right, so you're actually getting.
Yeah, I'm doing
a
the
link,
hold up, I can just,
like the Google one.
I can just do it. Yeah, I'm just doing the Google one now. And it's giving me like I've had dial-up better than that, but
Yeah, but did you pay like $4 for your?
no, I didn't.
Yeah. So I mean, this is it's symmetric.
I
That's
no,
good.
I was gonna say I get faster up speeds than I get down. speeds.
Yesterday I was getting about 5.
Okay.
Which
5
was
is enough to watch like a 720p YouTube video, I think, or maybe.
Yeah, I was very mildly impressed. So again, this is a super cool project. You'll probably see it pop up. This also, we had a lot of problems while doing this because Michael's computer was not routing properly over the network when we were connected to our normal access point, and this literally died. We were just sitting here trying to figure out like which cable was broken, and this was just fried. So we just had to accept that this is dead. Don't know why, but we got another one, and the ESP32 works just fine. So. Yeah, if you want to find an interesting project that's going to allow you to either act as a range extender or, alternatively do some cool security stuff, this is a great way to set up an access point that you can attack all day, not get in any trouble overdoing. And if you have IoT devices or other things that need smaller amounts of data, it can be a reasonable way of extending your range for your Wi-Fi, maybe into your yard or somewhere else where you want to have like a lower perimeter device you can keep an eye on that's managing the connections for others. So
Absolutely.
yeah, very cool. So that's all we have for today. If you want to see more of what we can do with one of these ESP32 NAT routers, I think they're really cool and exciting. I just hate it when they die like that because I really thought I was doing something wrong for the longest
Well,
time.
honestly, the great thing about this is even if you do kill it somehow, like it's what, like $2-3?
Yeah, this was like $4,
Yeah.
I think. So, it's sad that it's dead, but again, I'm more mad at it than I am.
It does make
sad
me
about it.
think about like the potential of this as like a Wi-Fi throwable. Like you could, attach a light poly battery to this or something like that, and like throw a network anywhere you wanted it.
Yeah.
'Cause that could be potentially useful.
Definitely. All right, so that's all we have for today. Thank you guys for joining us. If you want to see some more great Furnace content, you can always check out the Threat Update, which has our sometimes co-host Killian on it, talking about how real companies are reacting to threats. And yeah, that's all we have for this week. We'll see you next time. Bye.
Bye.